Hey everybody, Miss Kirkweld back again to talk about a little bit more about waves today. You'll notice that today's video, it says this folder is empty, but obviously this video isn't it for you. This video is the only thing we're going to need because we're going to go back up to Wednesday into our wave notes. So if you want to go in there and open up the wave notes, and then we're going to go down to slide 11. Remember, just like yesterday, you can put this video in half, and then you can have the other half be um, the notes so that you can have both open to take them. So feel free to pause and whenever you need to just to kind of catch up. So today, our essential question, the thing that I want to focus on today is um, what? I'm trying to figure out how to phrase it. Let's do how. How can we describe waves? So we know that we can have a mechanical wave, an electromagnetic, a transverse, a longitudinal, but how do we actually describe those waves? The best way I can do it is this, and you can either watch me or you can open this up if you would like to. So I'm going to open up wave on a string, and when I open that up, it's going to go here. There's a manual one. I'm going to put it on oscillate because we have some new vocab words down here that I want to show you. So I've got this one word, this is amplitude, and then I've got another word over here, this is frequency. So I'm going to figure out what happens if I change amplitude or I change frequency. So let's put those in the middle. Sorry, I changed all the settings because I was having fun with it. So and let's put it in normal. I have everything kind of in the middle here. We see waves. Think about transverse or longitudinal wave. Hopefully you said transverse wave, up and down, up and down. Longitudinal, each of these will be pushing each other all the way through. So we're going to change a couple of things here. I want to change amplitude. So if I change amplitude, watch what happens to the wave that's being made here. So I increase the amplitude. So what's happening to the wave? You should be able to see here that the wave is getting taller, right? So it's getting larger. And if I decrease the amplitude, now our wave height is getting a little bit smaller. So I'm going to leave it right in the middle. Then we also have frequency. So if I have frequency here, if I increase the frequency, we can see that all of a sudden there's a lot more waves happening here. And if I decrease the frequency, we can see that there's a lot less waves here. Now, if you're actually in this and you want to play around, people, there's always the one kid who breaks it. I'm sure that'll be you, where you can make the amplitude go crazy and the frequency go crazy, and then get rid of this and get rid of that, and then things just go off the rails very, very quickly. But we saw that amplitude has to do with how high the wave is, and frequency has to do with how often we see that. So in our notes, if we go down here to vocabulary 1, we have amplitude, frequency, and then this thing called wavelength. So amplitude was kind of how high that wave went. So we can see here, this is, well, let's put it like this. Amplitude is a measure of how far the particles in a medium move away from their normal rest point. So how far did it move away from that center line? Okay, amplitude measures that. Frequency is going to be the number of cycles such wave, the number of cycles in such as a wave given amount of time. So, and then we have wave length, which is the distance from any point on a wave to an identical point on another wave. So let's draw, oh, sorry, we got a little bit more vocabulary and then we're going to draw them out. So on slide 15 here, we have 3 vocab words. We have hertz, we have wave period, and we have wave speed. So Hertz is the scientific unit for measuring frequency. So if you've ever seen like megahertz or something like that, I think it's abbreviated MHz. If you've seen that before on a radio or something like that, that's because that's how it's measuring how the frequency of those waves. So a wave period is the time required for one cycle. So how long does it take for one wave to happen? And then wave speed is just the speed at which it travels. So let's draw some of these words out. So we have amplitude here. So what I've done is I've given you a blank chart here. And what we're going to do is we're going to go to our line button here. And we're going to make it scribble mode. If you have touch screen, this will be really easy. I don't, so this is going to be hard for me. Try not to be too harsh. So amplitude here, okay, if we're going to draw a wave happening, that looks really, really, really nice. Okay, beautiful, love it. So this nice little wave here, and then I'm going to draw an arrow right here to right there. I'm going to make it a little bit bigger. So this part right here, this part is amplitude. So I'm going to make a text box too so that I know that that height of the wave height here, this is amplitude. How far away from the center did that wave move? Okay. So next one, wavelength. This one we're going to go back into, you can either use scribble. I'm going to use curve this time so it doesn't look quite as bad. With curve, if you go up, click on a point, oops, it's a little bit trickier. So if I go to curve, go up, click on that same, oh geez, I'm just going to use scribble. So if I have my wavelength here, there we go. So here, when we're talking about arrows, this part right here, from right here over to here, I'll make this line a little bit thicker too. Maybe not quite that thick. This part right here, from the top of this wave to the top of this wave, is wavelength. Okay, so I'll make a little text box so that I know that. Or I could take this same arrow and I could paste it, and you could say that from the bottom of this wave to the bottom of this wave. It could be wavelength too. Or if you wanted to measure from the start of one wave to the start of the next wave, could also be considered wavelength. So as long as you're measuring from the same point, that's why I like to do top and top, because it's very easy to see where the tops of the waves are. That is our wavelength. So if I go down to our last one here and we go to frequency, again, I'm going to scribble. But this one, I'm going to try it one more time. I think I can do it. Ugh. All right. Scribble it is. Sorry, everybody. You get to look at this. So if I go up, I'm going to come down. There we go. So I want to know what my frequency is in this image. So over the course of 5 seconds, what's my frequency? And it gets a little bit tricky because some people tend to go 1, 2, 3 waves. But if we go back and look at our frequency, it's the number of cycles in a given amount of time. So it has to be the full cycle. So the full cycle would be up, all the way back down, and all the way back to this starting position again. So that's one wave cycle. So it's not 1, 2, 3. If we see we have one whole one here, and then another whole one there, and then a half a one. So like 2.5 would be our frequency in this image. So I'm going to write that on here so that we know frequency is 2.5. I'm going to put in all caps, not 3. Whoops, not 3. There we go. Frequency is 2.5 and not 3 in this image. So please be sure that we make sure that we know what we're doing with that. So in summary today, I'm going to go back here. In summary today, how can we describe waves? We can describe them by their amplitude, their wavelength, and their frequency. So we can describe them in 3 ways. We can describe amplitude, how high the wave is, wavelength, how long the wave is, and frequency, how quickly those waves are coming. So that's all our notes for today. Hopefully you had a good week, and then we're going to take a look at some other readings and stuff again next week. We'll see you later. Goodbye.